All right, new chapter, functions. Let's go. All right, so we got several new things here to talk about. So we have the domain and range. So when you have quantities x and or two coordinates, so a set of coordinates, I should say, which would be x, y, x, y, x, y, x, y. All of the x values are considered the domain. The range would be all the y coordinates. So if I have x, y, x, y, x, y, there might even be more. I might have another one here. You know, there might be more. But even if I have that, all the x values would be the domain, and all of the y values would be the range. Okay, hopefully that's just a review for you. So where this becomes significant is when we talk about functions. So functions is a special relation of ordered pairs that there is each domain, x value, is paired with exactly one member of the range, the y value. So each x has exactly one y. So I can't have x, I can't have like 3, 1 and 3, 2. That's there is more than one value in the domain for the one value in the range, so that wouldn't work. So that would make it not a function. And we'll get into that more here in a little bit. And then the vertical line test. Okay, so we'll get to the vertical line test in a second. So if I have a relation that has, these are all ordered pairs, 10 this, 0 this, 10 this, 20 this. So when I look at negative 10, 0 goes to this, 10 goes to this, 20 goes to this. Perfect. Yes, this is a function because it has exactly one value for each x value to the range. So domain x, range y, one value each. This set here, I have a domain of x. Negative 10 is going to two things. So negative 10 is listed twice. That's your first key. If it goes to two separate things, because there are two going to one, no, because there's two values. So it doesn't follow the exactly one member in the range thing. Okay, so the vertical line test. Another way that you can determine whether a relation has a vertical line or not. I don't know if I'm going to actually have one here. No, it does not give me that option. Well, that's a bummer. Okay, so if I take this pencil and I keep it kind of sliding it across the page or the monitor, each time it only goes through one dot. So if I place the pencil on the left and I move it across, if each value in the x passes through no more than 1 point, then it represents a function. So if there were, for some odd reason, two of them here, if there was another blue dot here, then that would not have one value for each x value. That would not be a function. So determine whether this is a function or not using that vertical line test. Well, when I put the pencil through straight here, it goes through 1, 2, 3 places. Nope, not a function because the domain and range have more than one, or because x equals 2 is the one they use as their example, goes through 3 different y values. Cannot be a function if it does that. One that catches people a lot when it comes to the graph is that is a function. Vertical line test works just fine. If I go sideways with it, though, that is not a function. All right, so determine whether this relation is a function or not. Explain. Well, to determine if it's a function, it needs to have exactly one value per x, or in each domain value to the range value. So I'm going to start looking here. Negative 3, negative 1, 0, negative 1, 3. Was there a repeat? No, it is not or yes, it was. Here's the repeat. Negative 1 is listed twice, and it goes to different values. So negative 1 goes to 1, and negative 1 goes to negative 1, negative 1 goes to 1. It can't be paired with both things, so no, this is not a function. Determine whether this is a function. That is a terrible looking graph. Oh well. So I start looking. 7. Are there any repeats in the x values? 7, 6, 5, 2, 3, 6. I do not see any repeats, so that means they're all going. It doesn't matter what the y values are. It's only the x to determine if it's a function or not. So yes, each x value is paired with exactly one y value. All right, your turn, go. Okay, so I start looking at this one. 2, 4, 3, 6, -2. I don't think there was a repeat there. So I would say that in the x values, there's no repeats, so therefore it should be a function. All right, so x values here, 3, 1, -1, 3, -3, 1. Multiple ones going to different y values, not a function. So 1 is paired with 4 and 2 in the range. All right, so determine if this graph is a function. Explain. Well, this one says if we pass the vertical line test, so if I was going vertical, there it's fine, there it's fine, one time, we're good. Passes the vertical line test. All right, determine whether this graph is a function. If you're paying attention earlier, you would know the answer. Go. All right, so I start checking. Vertical line test, none, none, once, twice, not a function, does not pass the vertical line test. All right, so the table here shows the number of boxes that are made. Does the box here represent a function? Well, we'd have to figure out x and y. So if I make this my x values and this my y values, my domain has 3 different things. I have range has 4 different things. Should be a function. For every 10 hours, there is only one amount of boxes that are made. It'd be crazy if there were 2 different amounts being done at the same time by the same thing. So yeah, that'd be just weird. So that's one reason that this has to be or that we use this term function, is so that we can make determinations like this. All right, describe how box production is related to the number of hours. So as the number of hours increases, the number of boxes produced increases. So this is really just asking how are these correlated. You could actually draw them out if you really wanted, 10, 20, 30. And if we did like, I'm just going to make life easy on myself, 3, 6, 9, 1,000. We'll just say these are thousands. So I'd be here to here to here. So it goes in a positive manner. All right, on your mic, stay go. All right, so the number of hours. Does this table represent a function? 5, if this is my x, this is my y. 5, 10, 50, 20, one value. Yes, this would be a function. Only one amount of chairs is made for every 5 hours. All right, so describe how chair production is related to hours of operation. Well, as these go up, these go up. So I don't have to graph it. I can just kind of look at that. It goes up by 120 every time. So I can say as the hours increase, the number of chairs increases. And that's number 1. See you in class.